In this video, I'm going to talk about capacitors. Capacitor is nothing but it is a device in two conducting plates, two electrodes, separated by a dielectric material. Dielectric material is nothing but a paper, air, Teflon, polyester. These are all dielectric material. Now, next point is both plates are going to carry the same amount of charge but opposite charges. So here capacitor is nothing but we have a positive plate, negative plate. So two plates separated. These plates are conducting plates separated by a dielectric material. So this plate is carrying positive charge and this plate is carrying negative charge. Now the amount of charge each plate is carrying the same amount. So if this plate is carrying Q and this plate is charging negative Q, but altogether we will say a capacitor carrying a charge of Q, a positive charge of Q. Okay, now capacitor indicate with the C measured in farad. So the unit for capacitor is named after Michael Farad, who lived from 1791 to 1867. He's an English scientist who contributed or who studied about electromagnetism. Now we know that capacitor always creates potential difference. How? By separating two charges. Separating positive charge and negative charge. Here, as long as we have positive charge and negative charge, we know that there is always electric field between these two plates. That electric field is constant at any point of time, assuming the distance between these two plates d is very small. So the potential difference V equal to potential difference, voltage, everything same, V equal to E times d, where d is the distance. Sometimes you might see E times R, where R is also distance. Similar, V equal to E times R. Another important point is capacitor stores energy in the form of electric field. So the amount of energy it stores is half CV square. I'm going to derive that in another video, but it stores energy in the form of electric field. So as long as I put the charges on the positive plate and negative plate, automatically there is one electric field. So if I can hold that electric field, or if I can hold the charges on these plates for a longer period, the electric field is going to exist and it will be helpful to store energy. Okay, so that the amount of energy is half CV square. Another important point, capacitor oppose the rate of change of voltage. What it indicates, it does not allow sudden change in voltage. So if we need to change the voltage across capacitor, it needs some time to discharge that energy. Okay, so it is not possible to change the voltage across capacitor in zero time. We'll talk about this point again probably in another video. Now do not confuse battery with the capacitor. So battery is nothing but we will have a positive plate, which is very longer plate, and negative plate, which is very smaller plate. So positive and negative. Whereas capacitor, we see two plates with equal length. Okay, see in farad, or one plate is going to be bent like this. It doesn't make any difference. Both of them are indicating the same thing. Okay, and this is also C, this is also C, where this is a battery. So what is the difference between battery and capacitor? Both store energy, right? But remember, battery stores energy in the form of chemical energy. Capacitor stores energy in the form of electric field. So what is going on inside the battery? In reality, battery is nothing but it has a container and there is a chemical inside it, lead acid or lithium ion or zinc bromine. These are all different chemicals. Okay, so here, so lead acid battery is nothing but there is a chemical inside and two electrodes. Okay. One electrode is positively charged, another electrode is negatively charged. Basically, how come this is positively charged and another one is negatively charged? What happens inside this chemical will, take the electron, borrow the electron, or forcefully take the electron and give it to that electron to the negative plate. So when this electron from here, it moves from here to here, this gains energy. So when it reaches here, this has lots of energy. So all the many electrons, millions of electrons are moved from positive plate to the negative plate. That's how there is a potential energy is created. So that's how we say this is positively charged and this one is negatively charged. The other electrode is negatively charged. Now if I connect this to an external resistor, we'll talk about resistor in the next video mostly. Now what happens, all the resistors, all the electrons are going to travel in this path, lose their energy and reach to the positive plate. Again, the electrolyte inside, this chemical electrolyte, we call that as electrolyte, that chemical pull the electron, again give it to the negative plate. So it will continue that process. This is nothing but a battery. So battery, this process creating or pulling the electron from positive plate, giving it to the negative plate is called EMF, electromotive force. Okay, this is called EMF. Forcefully taking electron from positive plate and giving it to the negative plate is called EMF, electromotive force. Whereas capacitor, you have two plates. When we charge this positive plate, automatically there is a negative plate created or negative charge is created on the other plate. Now there is an electric field here. That electric field is constant at any point in between the plates. Now they both store energy, right? So can I use capacitor instead of battery? No, we cannot use. The reason behind it is battery supply energy in a controlled manner. Okay, so if you connect a battery to your flashlight, at least it will glow for a few hours, right, based on the energy available in that battery. Now if I connect a capacitor instead of a battery, the capacitor is unable to control its flow. Okay, it will quickly discharge all of its energy. So within few milliseconds or few seconds, that energy is gone. So your flashlight is going to just turn on and turn off immediately. Sometimes it may break the flashlight too. So you cannot replace a battery with your capacitor, because a battery convert chemical energy into electrical energy and it controls its energy flow, but whereas capacitor cannot control its energy flow. It discharges all of its energy in quick moment. Now we know that the potential difference between these two plates, so here is a Q, positive charge, of course this one has negative, same amount of negative charge. Now here is the potential difference V. Okay, we know that here is an electric field. Few important points I want to discuss here. So the electric field is here. Now since this is a negative plate, we always take negative plate voltage as 0. Okay, when we come at a different point, so the voltage here might be 10 volts, 20 volts, 30 volts, maybe 40 volts here. So the potential difference between positive plate and negative plate for this capacitor, V equal to 40 volt in this case. Now the electric field lines are perpendicular to the equipotential lines. So equipotential line is nothing but at any point on this line, on this vertical line, the potential difference is constant. So here say it is 10 volts, here also 10 volts, 10 volts, 10 volts. So what does it indicate? The electron, if an electron is here, it's not going to spend any extra energy to move from here to here, anywhere on this line. That's the reason we call this as equipotential point. So this equipotential line is always perpendicular to the electric field line. That's one of the important point you need to know. So this V equal to E times D, where E is the electric field, D is the distance between the plates. Okay, so we know that E is nothing but KQ over R square. Okay, so basically electric field is proportional to Q. Based on this, can I say V is also proportional to Q? So if I have more charge here, you can use the bigger letter, doesn't matter. So if I have more charge on the plates, I can say there is more potential difference between those two plates. So in the opposite way, I can say Q is directly proportional to V. So to remove the proportionality constant, I'm going to introduce a new term called C times V, where C indicates the capacitance in farad. Okay, capacitance in farad. So the C is nothing but the capacitance value. By the way, this capacitance is independent of Q and V. Okay, when the manufacturer make the capacitor, it's nothing but two conducting plates separated by dielectric material. It's a very simple device. Okay, so when we place two conductors separated by dielectric material, a capacitor is formed. Now this capacitance, when the manufacturer made this capacitor, the capacitance value is fixed. It is independent of how much voltage you are applying, how much charge it can store. Basically the manufacturer is going to define this and this. So manufacturer is going to define the capacitance value and voltage value. So C is independent of Q and V. So here we have a capacitor. Capacitor is nothing but two conducting plates separated by dielectric material. Here the separation between those two is distance D, where D is the distance between the plates. Capacitor or parallel plate capacitor, both of them are same, do not confuse with them. Now from the previous chapters, we know that E, electric field between those two at any point, is same, E equal to sigma over epsilon naught or eta over epsilon naught. So some books using sigma, some books are using eta. Now that sigma equal to eta equal to charge per unit area. So eta equal to Q over A. So E equal to Q over epsilon naught times A. Now VAB, which is potential difference between A and B, equal to VA minus VB, or you can write it as VBA equal to VB minus VA. So VAB is nothing but negative VBA. Okay, we know that voltage is a scalar quantity, but personally I believe that I do not agree with that, because this is the reason. I can write VAB equal to negative VBA. So it has direction. Which direction you are indicating is also important. So I believe that voltage is a vector quantity, but as I mentioned, I will follow the textbook for this class. So the textbook says voltage is a scalar quantity, so we'll go with that. So voltage is a scalar quantity. Now VAB equal to, so the potential difference between these two, we know that V equal to E times D, right? So what I'm doing, D is nothing but distance between the plates. So I can write V equal to E is nothing but Q over epsilon naught times A times D. Okay, I indicated that in a different manner here by integrating all those things, but you will end up with V equal to Q over epsilon naught times A times D. We already know, we just found that Q equal to CV. So if I substitute C equal to Q over V, so I'm going to bring the V right here. So Q over Q times D over epsilon naught A. So Q get cancelled out. So C equal to epsilon naught A over D. Okay, epsilon naught is a constant and A is the area of the plates, D is the distance between the plates. So as long as we know the area of the plate and the distance between the plates, we can find the C value. So the manufacturer, when he manufactures, this is how he determines the capacitance value. He will know what is the size of each plate and the distance between the plates. Based on that, he will give us the capacitance value. I will stop this video here. In the next video, I will talk more about the capacitor. Thank you.